In this chapter, we're going to be looking at chemical bonds and the different types of chemical bonds that exist in chemistry. But before we do that, we're going to look at why elements want to bond. There are two main types of elements. There are elements that are already stable the way they are, and then there are elements that would like to become stable. So you want elements to have a stable electron configuration. That means the highest energy level needs to already be filled with electrons. So noble gases fit this. In a previous video, I had talked about how the noble gases are very unreactive, and that's because their highest energy level is full already. So for all the other elements, we create this electron dot diagram, and you can do it for a noble gas too, but it's very helpful for the other ones so that you can see how many valence electrons there are that you might want to bond with another element. So an electron dot diagram is just a model of the atom where it only shows the valence electrons. It doesn't show any of the other ones. So for instance, let's look at magnesium, and you need to draw this in your notes as well. So magnesium is in the second representative group, and so it has 2 valence electrons. So to show that with a dot diagram, you just put 2 dots around the element magnesium. Hence, those 2 dots represent the valence electrons for magnesium. If we do chlorine, chlorine is clear over in group 17, so it has 7. So it doesn't really matter where you put them, as long as you have 7 dots. So those would be the dot diagrams. Now, some other bonds that maybe are not as common, we have van der Waals forces. It's not really even a bond per se, but it's just a very weak force that elements can experience when they're at very low temperatures, where they're kind of attracted to each other. We have hydrogen bonds. These are a little bit more common. This is a bond that exists between hydrogen, and hydrogen is this white one right here, and another element. And notice that it's not within, okay, so this is one water molecule, and oxygen bonds with hydrogen, and it actually bonds with 2 hydrogens. A hydrogen bond exists between hydrogen and the oxygen of a completely different water molecule. So this would be an attractive force, hydrogen bond right here, between hydrogen and oxygen from a different water molecule. Now, some bonds that you're probably more familiar with are covalent bonds. Covalent bonds are where 2 atoms are going to be sharing their valence electrons. And this only takes place between non-metals. So key right there, highlight it. Absolutely need to know this, because later you will need to be able to identify when you're given a formula if it is going to be a covalent bond or an ionic bond. So you need to be able to know where your non-metals are so you can identify a covalent bond. With covalent bonds, there's a group of elements. There are 7 of them. I'll put that here, 7 of them, that are considered diatomic elements. And these are elements that will bond to themselves, and these are the only 7. So whenever you have hydrogen, hydrogen actually will bond with itself. So it will form a bond between hydrogen and another hydrogen. So that's what diatomic is referring to, is 2. So they come in pairs. There are 2 types of covalent bonds, and it really depends on how the electrons are shared. So some kids, when you're growing up, share really easily, and they like to share their things, and other kids are not very sharing, and they're kind of stingy. So we have 2 types of sharing, one where they share equally, and another where they don't share equally. And polar covalent is when they do not share equally. And so this would be where one atom has a greater attraction for the electrons. So it's going to be slightly negative, and the other one is going to be slightly positive. Water is a good example of that, because water is oxygen and hydrogen. Hydrogen's a really small atom, and oxygen's kind of larger. So when they're sharing these electrons, okay, these electrons, I tried to draw an arrow on both sides where the electrons are kind of going back and forth. But oxygen's a bigger molecule. It's kind of like a bully. And so it's going to want to keep those electrons more often. So it's unequal sharing. This would be another example. Okay, you have hydrogen with chlorine. Chlorine is the much bigger molecule. It's going to want the electrons more often, so unequal sharing. The other type is called nonpolar. Nonpolar means that they are shared equally. And this will always happen when you have two elements that are the same bonded together. So that's always going to share equally because they're both hydrogen. So they're both pulling with the same force. They both have the exact same properties. We can also have multiple covalent bonds. So double bonds are when you share two pairs of electrons. That would look like this. When you put, almost looks like an equal sign. Okay, that would be a double bond to show one bond and two bonds. You can also have triple bonds. This is where you share three pairs, and each pair is two electrons, so you're up to 6 electrons. Nitrogen can form a triple bond with itself, so you would show that with 3 lines holding it together. The other type of bond you might be familiar with is ionic, and this is a transfer of electrons. So one element is going to gain and one element is going to lose. Key, absolutely have to know, star it. You need to know that an ionic compound is between, or an ionic bond is always between a metal and a non-metal. And an ion, since you get the word ionic bonds here, an ion is any atom that has a positive or a negative charge. Some other vocabulary. A cation. A cation is anything with a positive charge. So you're going to see, for example, sodium. And you'll see the charge written kind of off to the right-hand side and up. So it's not really right beside it, but it's a little bit up and to the right. You also have negative ions, and they're called anions. And chlorine would be an example of this, with it has a negative charge. And there's going to be an ionic bond between a positive and a negative. So a plus and a minus, it can't be between two pluses, and it can't be between two minuses. It has to be a plus with a minus in order for it to be an ionic bond.